Ever wondered about the invisible forces that drive your computers, smartphones, and other digital devices? Memory modules are one of those unseen yet crucial components that keep your devices running smoothly. To simplify, a memory module is like a storage unit where a device stores data that it needs to access quickly. It's like a library where the device can quickly retrieve and store information when needed. Each memory module contains several memory chips, and these chips are like the individual books in that library. Now let's break this down further. Consider a memory grid, represented as M, where N signifies the number of memory spaces and D stands for the embedding dimension. Each column, MI, in this grid, represents a single memory space. This framework isn't just a dormant storage unit, but an active participant in the computational process. The choice of N and D balances the trade-off between memory capacity and computational feasibility. Moving on, there's a process called key-value pair generation. This process begins with the generation of a write key, KW, and a corresponding value, VW. The write key acts as an addressing mechanism in the memory system, while the value represents the content to be stored. Next, the system addresses and updates the memory space. This is done through a softmax function where Y represents the affinity of the write key towards the ITC memory slot. This function ensures a differentiable and probabilistic approach to addressing, crucial for training through backpropagation. The memory space is then updated using a decay factor lambda. This factor regulates the rate at which old information is forgotten, preventing the memory from being overly influenced by recent inputs while still allowing it to adapt over time. Output. Now, onto the reading part. A read key, KR, is generated from the decoder's output. The generation of KR is similar to KW, but derived from a different part of the architecture, reflecting the need to retrieve relevant information for the current decoding step. The content retrieval process is numerically calculated, reflecting a soft retrieval mechanism, providing a contextually relevant piece of information for the current task. Finally, the memory module integrates with the transformer's self-attention mechanism. This integration involves complex modifications to the standard attention computations, resulting in expanded matrices of queries, keys, and values. To summarize, memory modules are essentially the brain of your device, storing and retrieving data as needed to perform tasks efficiently. They generate write and read keys to address and update memory spaces and interact with the transformer's self-attention mechanism for efficient computation. Remember, just like a well-organized library enables quick access to books, a well-functioning memory module ensures smooth and efficient device performance.